Welcome back to some more geometry. Today we're talking about postulates and paragraph proofs. Now, paragraph proof doesn't mean you're writing a whole paragraph. It just means you're going to be writing some words. And these words will be these right here. All right. So let's talk about postulates first. Now, postulates, also known as axioms in some books, are a statement that is accepted as true without any proof. We don't need any proof. So, for example, Donald Trump is the current president of the United States. We don't know no proof. We just take that as true because it is. And the Thunder is the professional basketball team in Oklahoma City. Again, those are all taken as true statements. We don't need to go fly over there to see if it's true. We know it is. So, based off these ideas, we're going to be talking about postulates that has to deal strictly with points, lines, and planes. Now, as we've been going through this chapter, we have talked about these specific things, but we're going to make the exact postulate because these postulate 2.1, blah, 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 2.2, all the way, I think we have how many? 3, 4, 5, 6, 7. 7 different postulates that we'll talk about today. They'll be used to as the statement, as the reason of why the statement that the question made is either true or false. So, for example, 2.1 says through any 2 points, there can only be one line. I cannot draw another line. If I draw another line from here to here, I'm just drawing the same line over again, over and over again. So, through any 2 points, there's only one line. So, this is what you're going to need to write down as the reasoning of why something's true in your homework. No, so line M is the only line that can go through point P and R. Now remember, they call this line M, but you can also call this line PR. Put a line sign above it in case we forgot. Now, through any 3 non-collinear, and this is important, this next postulate, through any 3 non-collinear points, there exists one plane. The reason we have to say non-collinear, as we'll see here in a bit, sometimes when they're straight in line, they can have multiple planes go through it. But through any 3 non-collinear points, meaning on the same line, there exists one plane. So, for example, here, their statement is plane K is the only plane that contains both, that goes through non-collinear points A, B, and C. A, B, and C on the straight line, so we have a plane that exists there. All right. Now, since, like we said earlier, back in 2.1, through any 2 points to exactly one line, well, a line contains at least how many points? At least 2. You can have multiple points, but you have to have at least 2 points. And a plane contains at least 3. So earlier we said it needs through any 3 non-collinear points, there's exactly one plane. Well, through one plane, there's at least 3. You can have more than 3, but you need at least 3. All right. So here we have 4, but we only need at least 3 that are not on the same line. And this last statement down here. If 2 points lie in a plane, so if 2 points are on the plane, so for example, here we got plane K, and we got points A and B. Okay. Then the line that connects those two and every single point that's on the line. So if I make new points, let me change the colors, go black. A point there, point there, point there, point there, all that are collinear with that. All the collinear. Every single point that's on that line is also on this plane. So if 2 points are on a plane, we know for sure, then the line that exists and every single point on that with that line, found within the line, are also on the plane. That'd be very important because we'll talk about that here in a bit as one of the questions I'm going to ask you for you guys to work on. Now, and this is very important. If 2 lines intersect, so 2 lines, and we talked about this before, 2 lines intersect, that equals 1 point of intersection. So if 2 lines intersect, their intersection is exactly 1 point. And if 2 planes intersect, so 2 planes intersect, that equals 1 line. So 2 planes intersect, there is an intersection is a line. Now, this is kind of hard to tell, but this is kind of going through each other. So that's where we kind of have a hard time seeing that. But earlier we talked about how the very first one here, 3 points have to be non-collinear. The reason being is if they're collinear, so let's say, for example, there's 3 points on this line W right here. Say 4. If they're all collinear, they technically exist in both plane F and plane G because they intersect, makes a line. Well, lines contain points. That means all those points right there exist on this plane and this plane over here. So it's very important that when making that statement, we have to say non-collinear. Non-collinear. All right. So a proof, again, is a logical argument in which we make and we give examples to make or hold the statement true. So we can use this in real life. I was not speeding, officer. How do you know? Where's the proof? Here's the proof. I have a dash camera that shows my speed. It says I was going 64. The speed limit is 65. Or something like I was on time. Or, for example, this is when it happens like, hey, I turned in my homework. How do I know you turned in your homework? Like, here's a picture of the homework I submitted, or I did my homework. So these are all log arguments, and you do these naturally already with your parents, with your boyfriends, your girlfriends, with your friends. We make arguments. Not, we don't argue, but we try to make logical arguments and not to try to have our emotions into it. That's the difference between a proof and just a regular argument. Is we're making a logical statement to support what we're trying to do. Now, theorems are statements that have been proven. Okay, we will talk about theorems later, but theorems are statements that have been proven, and we will prove a couple of theorems to show why these are always true. But a paragraph proof is just an informal proof. You're going to write out saying, hey, this stuff is true because blah, 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 blah. Well, let's check it out. So we're going to kind of do it right here. So here, the example is, hey, they're telling us M, K, and N. These 3 points right here are coplanar. Looking at this picture right now, you will say, no, they're not coplanar. Look, M's above. But they are coplanar, just those 3 points only, not because earlier we said through any 3 non-collinear points, there's exactly 1 plane. So we can make a new plane that connects those. So we will say true 2.2 through any 3 non-collinear points, 2 L's, non-collinear points. There is 1 plane. So technically we could make a whole new plane right there. So it is not wrong to say those 3 points as they are, just those 3 only, not based off the picture only, but those 3 points can be coplanar in a whole nother plane. Now they say, hey, are these coplanar based off the figure? Then no, they're not coplanar based off the figure. And that's why on your assignment, I think in 1.1, yes, 1.1, or yes, 1.1, they always gave the example of 4. They said, hey, point M, A, K, and N, are those 4 coplanar? Then that's a no. But to say 3, then you could make the assumption, yes, 3 points are coplanar, can be coplanar. Now, line NE contains point M and N. That is true. Why? Because, as we said earlier, this right here, a line contains at least 2 points. A line contains at least 2 points. So we're talking about a line, even though it's being named line NE, there needs to be at least 2 points, and it contains those 2 points. So yes, that was 2.3. 2.3, what was it again? Ooh, sorry about that. A line contains at least 2 points. A line contains at least 2 points. So it contains at least 2 points. All right. Let's try another example. So you'll have a couple questions like this. Is it always, sometimes, or never true? Are they always true, sometimes true, or never true? So point X and Y are in a plane. So any point collinear to X and Y are in plane Z. True. Is that always true, sometimes true, or never true? Hopefully you pause, thought about it, look at your notes, and you say, yes, that's always true. Why is it always true? Because, like we said earlier, right here, hey, if 2 points line the plane, then the entire line containing those points lie in that plane too. So, as I said, any points collinear to x and y are all on that plane. So all those points are on the same surface. So yes, A, B, and C determine a plane. Always, sometimes, or never true. All right, so you pause, looked at your notes. All right, let's see. That is sometimes. The reason is sometimes is because it doesn't say they're collinear or non-collinear. It just says 3 points. So it's sometimes true because they could be non-collinear, which equals plane, one plane, a plane, or they're collinear, which equals many planes. You can have many planes, many planes. So that's very important, the verbiage and the words they use. What does they mean? All right, y'all. Y'all have a great day. Holler at me if you need help. Please, please, please. Take care, y'all.